So P3 minus, yeah, means there are three more electrons than neutral phosphorus. So it's isoelectronic, or the same number of electrons as, or isoelectronic with argon, right? So P3 minus, if you have phosphorus here with 15 electrons, if you add 3, now you get to argon's configuration. Okay, so it would be, you could either put just this, or you could do the whole, that 2s2, 2p6, 3s2, 3p6. Okay, so either one of these would be the right answer. Okay, so I guess they want it all the way, but yeah. Okay, so any questions about ions? We're going to do more of these. That's really the topic of the new chapter, but okay. All right. For the main group, it's kind of easier to talk about ions. It gets a little more complex for transition metals. So I think that, you know, that'll be kind of the topic for chapter 6, really, is talking about these ions. Okay, so we'll get into that, I guess, probably tomorrow. We'll get into these transition metal ones. Okay, all right, so those were the homework ones. Now, let's do some new Chem 101s. So in class, here we go. Okay, and I've got a bunch of these, so let's start with this one. So config 1. And yeah, let me load all these up here. Four. Five. Okay. Yep. There we go. Okay, whoops. Okay, so let's start with config 1. This is slow here today. Okay, here we go. Okay, config 1 is a student draws the orbital diagram. Let me blow this up here. There we go. For the 3p electrons in a sulfur atom, what is incorrect? Let's see. Okay. Yeah, so everybody so far, except one, is correct. Yeah, so this is Hund's rule. Yeah, so we really didn't talk, Heisenberg uncertainty just really relates to, you can't know its position and momentum at the same time. And Pauli exclusion principle says you can't have two electrons with the same set of 4 quantum numbers, but each of these has different numbers. So it's, Hund's rule. Yeah, so this last electron, if I blow it up a little here, this last electron had to be spin up. Okay. All right, good. Now config 2. Which of the following electron configurations is incorrect? So these, by the way, are really, really typical of questions that I always put on your next exam too, your next midterm. Okay, so incorrect configurations. right. Yeah, this one was pretty easy to spot, wasn't it? So, what's the problem with it? So why is this incorrect? And you are correct that that is the wrong one, or the incorrect one.
Sulfur and neon are on the same level.
Yeah, so sulfur. Yeah, so you could put so the configuration really for sulfur should be neon, 3s2, and then 3p4, right? So the problem here is that you can't have more than 2 electrons in the s, right? So you'll never have a s3 configuration, okay? All right. Come on. There we go. Then configuration 3. Okay, noble gas core in the electronic configuration of ytterbiums, YB. So if we got the periodic table, so you have that in front of you, there you go. So the element is down here, so it's that one. So element 70. And so that means it's xenon. Yep. So the row just above it. Okay, so again, remember these are all inserted in here. So the row above is xenon. Okay. So that was 3. Okay, configuration 4. Okay, and here's this term, isoelectronic species. So that means which of these pairs has the same number of electrons? So I wonder if I can, yeah, maybe overlay this here. Let's see. There we go. Okay, you're still thinking? Okay. Yeah, so the majority so far are picking A. And so that is correct. Yeah. So looking at these different combinations here, so A is correct because magnesium 2 plus is the same as neon, right? So you've got 12 electrons. If you take 2 away, that's neon's configuration. And O2 minus, you have 8. If you add 2 electrons, that's also neon, okay? Versus K plus would be what noble gas? Potassium plus.
Argon.
Yeah, it's argon. But lithium plus is which? It's helium, right? So they're 2 different noble gases, so they're not the same. Calcium 2 plus is the same as argon, and F minus is the same as neon. Okay, so again, they're not the same. Iron 2 plus is, kind of here, and S2 minus is a noble gas. Okay, so they're very different. And aluminum 3 is the same as what noble gas? aluminum 3 plus. So if you take 3 electrons away from aluminum, you get
Neon.
yeah, you get neon. Yeah, good. But Cl minus is argon. Okay, so again, they're different, so they're not isoelectronic. Okay. And then the last one here, configuration 5. Okay, so which element has the ground state configuration of that? Let's see what you're thinking here. Oh, okay. Yeah, and I think this has to do with the way this periodic table is laid out, actually. Let me get a better periodic table. Maybe this one? No, that's the one. Okay. Whoops. So the answer is not rhenium or Re. Let me show you why. Is that bigger? No. Here we go, this one. Okay. Good old Wikipedia. Okay. So if you look at it this way, so in this periodic table, whoops, which one? Let me go back to the one it was. Dynamic periodic table. Okay, this one. Okay, this one, it made it look like all these are in the lanthanide. It should be that element 57, and then if you read across, there's 14 here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's really 58 through 71 are inserted. And so the better periodic table is actually this. Okay? So this is your, that's why, you know, it goes to like a D1 and then F whatever, and then you get back to your Ds. Okay? And so, so for this, 6s2, 4f14, 5d4, you're going here, so it's 6s2, and then you do your 4f14, which is all these, and then your D's are really from here, so it's 1, 2, 3, 4. Okay, so 5d4 would be actually tungsten. Okay. So did everybody get that? Okay, so this is showing really that your D, so lanthanum in other words, is a D1, and then this is your D2, D3, D4. Okay, because all these guys are inserted in there. Okay, so yeah, the answer here should be tungsten. Okay. So let's talk. Actually, you know what? Yeah, let's just go through this slide, which I think we pretty well already talked about. But um, ions mean that we're just taking away or adding electrons. And so if we have, for the main groups, is what we're just going to talk about today. And then tomorrow we'll get into the transition metals, which get a little more complicated. For the main group, you're just taking away one electron. If it's sodium plus, you just take away the electron that's farthest from the nucleus. So it's the 3s that would go away. Okay. And for chlorine, you're adding one electron to this. And so this is why the halogens like to add electron. This is why Cl minus is so preferred, because this configuration has all of the orbitals filled. Okay, so it's a noble gas configuration. Okay, and then likewise, sodium plus, if you take one electron away, you also have a noble gas configuration. Okay, so the group 1s love to be +1, and the group 17s like to be -1. Okay, so so if you look at the periodic table, then you can, what do you do with it? Yeah, you can start to understand why they had the preferred charges, like N3 minus is the same as neon. Okay, so I think that's where we will end today, talking about these main groups, and we will pick up on that tomorrow.
So I just have one question.
Yes.
So if you have an electronic configuration, so like how you had for I'm guessing chromium, it's like 4s1 and 3p5. So if you had to take away an electron or add an electron, how would it work?
Yeah,
would it be added to the s? Or?
Yeah, so for the chromium, you're talking like the transition metals here?
Yeah.
Yeah, so we'll talk about that tomorrow. Yeah,
okay.
It turns out for this group that you're actually going to lose the S's first, and then you will take away from the D's. And so we'll talk about that tomorrow. Yeah.
Okay, thank you.
Okay. All right. The slide again. Okay. Let's see. There we go. Okay, so any other questions before we sign off?
What's the name of the video I should look up on YouTube to get the Friday Thursday lecture?
Yeah, it is March. What did I call it? It is called March 25th, 2020.
March 25th. All right, thanks.
Yeah, you're welcome.
Also, I found it helpful to go to the announcement on Blackboard, because there's a link directly to the list of all the videos.
Yeah, the
so
playlist.
You don't search for it.
Yeah, and I just pasted the playlist on the chat. So.
Yeah, thank you. Yeah, thank you for doing that. Yeah.
Not that dandy. All right, see ya.
Okay, all right. Enjoy the rest of your day, everybody.